Our next guest is Valery Vermeulen, possibly one of the most intriguing musicians out there. He has a PhD in mathematics and also a master's degree at music production. He mostly focuses on the intersection between art and science. He has made music based on the simulation models of black holes. And he released a new album called Micromedas ADS/CF2001. This was picked up in 28 countries worldwide. And he even got an honorary mention for the Staes Prize, awarded in name of the European Commission. His work personally makes me think of this one story that I recently read on Twitter or X, I don't know anymore. But it's about this one girl that just couldn't grasp the idea of physics. So she then just came up to a guy she knew that had a physics major. And she asked him, well, tell me about physics. Explain it to me as if you are in love with me. And after a brief silence, he answered, well, I guess everything sings. And to me, that's absolutely true. Everything sings. The universe sings. There are a million powers here present in this room already, like the powers of gravity keeping us from floating around in this whole room, or the sound waves of my voice reaching your ears, and millions of others. The universe is constantly singing to us, and we just have to listen. That is exactly what our speaker is trying to show us. I present to you Valery Vermeulen.
So I am the last speaker, so I'm going to try to take you on a journey, the last journey of this evening. It is a journey that is motivated by power, but under another format than we heard before here. I got into power, you could say, in using the power of physics. So, and the red wire through my story is, on the one hand, music, mathematics. So those are two passions that I have. And I found a way to merge those two together using the four fundamental forces in nature. So what are the four fundamental forces? These are gravity. That's why we all are sitting or standing here on the earth. You have the force of electromagnetism, that is everything that has to do with electricity. You have the strong nuclear force, that's the reason why we have atoms, otherwise they would never exist. And we have the weak nuclear force, and that is everything that has to do with radioactivity. Now, as a teenager, I was always very curious, and I got very interested in physics by finding some books on quantum physics in the library, a long time ago, when people still went to libraries. But today's, I think people still go today. But I was really intrigued in this book. There was, I read about the four fundamental forces of nature, and there was this question, these big questions in physics, and one of them was finding a theory of everything. So that really sparked my imagination, and a theory of everything in physics is finding a theory that could encompass those four fundamental forces in nature, because when you raise energy, if you would raise the energy in this room to very high degrees of temperature, it is believed that those four fundamental forces would converge, they say in physics, to one superpower. So, and another problem that really sparked my imagination was the problem of finding a solution for the problem of quantum gravity. And quantum gravity is finding a theory that would encompass, on the one hand, the theory of Einstein, so that's the theory of general relativity, describing everything that or moves very fast or is super heavy, and on the other hand, the world of quantum physics, which describes the super microscopic small world. So as a result, I started studying mathematics, just because of the idea of trying to become a theoretical physicist. That was a little bit the plan. So I did a PhD in the world of mathematics. But at the same time, I had another passion that was music. And still today, I cannot choose between one or two. So I looked for ways to combine those two. As to music, after my PhD, I started experimenting with music production, and then I studied at KASK Conservatory School of Arts, and where I'm also teaching now, and in the music production department, I studied music composition with a specialization in music production. Now, after this, I had some ideas to combine, to merge my interests in physics and music, and it really took off in around 2014 when I started a project which is called Micromeras. And with this project, the idea is to make music using data coming from space, from deep space, and recently also from astrophysical simulation models and simulation models coming from the world of theoretical physics. And this got me into a way to try to move back to this problem of quantum gravity. Because in 2016, I had some first experiments with this Micromeras project. I made a first series, a sort of an album, focusing on a hypothetical journey of the Earth to the center of the Milky Way. The idea was to try to represent it using sound. After that, I really got into the question again of quantum gravity. I started studying a little bit again, and there I discovered that everything in physics, so one of the big phenomena, if you could understand them, that you could also understand quantum gravity, is the phenomena of a black hole. So an astrophysical black hole, I think you heard about it. We took a picture of a black hole not so long time ago. A black hole is a point in space, or in space-time, if you would use the words of general relativity, with the property that it has a center. And the center has a property that its gravitational attraction is so strong that if you come too close, you can never escape its gravitational pull. Now, okay, but how can you make music with it? That was a question that I was asking myself. And it started by a co-production with Concertgebouw in Brugge, and they got me into contact with Thomas Hertog. He's the physicist who worked with Stephen Hawking. So, and they said, Concertgebouw, can you not collaborate with Thomas? We want you to make music, and Thomas will do a talk. And that was a start, and I started working with gravitational waves. So here you can see gravitational wave. What on earth is a gravitational wave? Well, gravitational waves are waves that are being generated, for example, by mergers of two black holes. So when you have two black holes in space, if they like each other, it's a little bit like, you could say in the real world, it's a date, you could say. They can go on a date and they start swirling around each other. And if they are close enough, they can merge and form a bigger black hole. Now, this is such a cataclysmic event that it will generate gravitational waves. You can see the blue line and you see the waves and the simulation here. And if you would walk into a gravitational wave, what would happen is you would oscillate, you would become bigger and smaller and thicker and thinner using the gravitational wave. So I think there's a division by zero here. In mathematics, you can never divide by zero because then you get to those frozen movie parts. And now the black holes are merged and you have those gravitational waves. Now the idea was, what Thomas said to me, can you not make tracks using those gravitational waves? And the first piece I'm going to play for you is a track using gravitational wave data. Now, after this first experiment, I started thinking, maybe, because it was a first idea, if you can do something with those gravitational waves with data coming from simulation models of black holes. And I started working towards an album. And one of the ideas that was also used in the album, and that's related to the force of gravity, is the idea using the idea of brain cosmology. And basically, the question here that people ask themselves, physicists and scientists, is how many dimensions does reality have? Of course, whenever you ask it to a sane person, normally you would say we have 3 spatial dimensions. I can go front, back, left, right, up, down, and there is time, so there's 4 dimensions. But in the world of string theory, is a theory that states that matter is built out of tiny little strings. There's several versions. The first version said, no, there is 23 different dimensions. So really crazy. Then there were 10 dimensions, and now we are in, I'm using a model with 5 dimensions. So now, why on earth would you consider a 5-dimensional reality? Well, it is a method to try to explain the big difference between the force of gravity and the other forces in nature. So the full gravitational pull of the Earth weighs on our bodies, but if I would take a little coin and I would take a little magnet, just using the little force of electromagnetism of this magnet, I can overcome the full gravitational force that the Earth exerts on this little coin using just a little piece of a magnet. So, and one way that you could use to try to find a reason for this is maybe presuming that there is more than 4 dimensions. Now, the next piece I'm going to play for you was a collaboration I did with the University of Alabama in the US, and they're specialized into these brain cosmological models. So in a brain cosmological model, you have a 5-dimensional reality. You have 2 4-dimensional brains, they called. And brains are generalizations of strings. It's like a drum brain. So it's like a string stretched out in 2 dimensions. You have 2 of those, brain 1 and brain 2. Those are 2 4-dimensional space-time. So these are realities. And brain 1, I've tried to draw, you see, home. That's where we live. It's a drawing, I mean. That's our universe. And you have brain 2, that is a parallel universe. Now you also see on this drawing open and closed strings. So in string theory, strings can be open and closed. And the only way to communicate between our universe and a parallel universe is using these closed little strings. Now, it turns out that gravitational waves are built out of these small closed strings. And what the people in the University of Alabama are doing, that I collaborated with, they are simulating behavior of gravitational waves in our parallel universe in brain 2. So basically what they do is they take a big black hole and they throw a couple of galaxies in the black hole. It's of course not so nice, but we don't know if there's life in this parallel universe, so we have to assume not. If you throw a couple of galaxies, what will happen is they will generate gravitational waves. They're made out of closed strings, and so they can go from the parallel universe, enter our universe. And I got the data from the research department of those simulated gravitational waves entering our universe. And the next piece I'm going to play for you is using those gravitational waves. Now, as a result of all this research, there is an album. That's the next. So that's the title of the album. I'm not going to explain the full theory. I mean, there is a physicist, of course. Yes, so you know probably ADS-CFT. It's a reference to the holographic principle, which is a very nice principle which was discovered in the 1990s. All right, so the last piece is using the brain cosmological model. last note, there is a silent disco. So if you want to hear more about the space music, there's a whole DJ set in the silent disco. So you can listen 1 hour to space music and dance to space music. Thank you also for inviting me.